Welcome you all in the 21st lecture of electronics measurement and instrumentation. In this lecture I will discuss the energy meter, the remaining part of energy meter, that is the smart energy meter, and the different digital counters that are used for the counting of number of pulses in different equipment like energy meter and voltmeter and frequency meter. So, I will discuss first the smart energy meter and then with the digital counter. So, this is the outline of my lecture. The smart energy meter, first the type of a smart energy meter, advantage, disadvantage, and then type of digital counters and their applications. So, in a smart meter when there is a distribution system, the utility office or the office that provides the electricity that needs the following things, means it can the load forecasting they need the system operation, energy accounting, system losses, and so many tariff design, system expansion, power quality. So, these are the so many qualities or quantities that they want to measure. So, this smart meter basically transfer the information from the consumer end to the utility end. So, this is the basic structure of a smart meter, and here this is the smart meter is placed at any home, and this is the utility office. So, utility office can monitor this smart meter through any communication mode, like it can use GSM, it can use high frequency modulation technique or any technique it can use, and it from the utility office it can measure the reading instantaneous value of the energy consumed, it can measure the highest energy consumed by that house, and this can be communication. The meter can communicate with the utility office, and if suppose the consumer is not deposited the amount which is demanded by the utility office as per the meter reading, then it can be cut the electricity by sitting at the utility office. They do not need to come to the house and then cut the supply voltage. So, these are the intelligent meters that can process and feedback the data to the customer, and these smart meters measure the energy consumption remotely, switches the supply to customer and control the maximum electricity consumption, and they are capable in both end. They can communicate with the utility office. So, these are the smart meters. So, they can upgrade the software, utility office can upgrade the software by sitting at the office, it can connect disconnect the meter. So, the automatically all the data is transmitted to the utility office, and whatever the action utility office want to take, they can take that action by sitting at their office only. Here the modems are used. Modems means modulation and demodulation devices. So, modems are used here to facilitate the communication system, because we need modem and demodulation, modulation and demodulation techniques for communication with the utility office. So, these smart meters have modems to facilitate the communication system, such as communication through fiber wires or through power line using GSM, GPRS and radio frequency. So, smart meters can be classified into following type, that is AMR smart energy meter, AMI enabled smart energy meter, smart card based prepaid energy meter, token based prepaid energy meter. So, these are the type of energy meter that are used today. So, first is automatic meter reading, AMR, automatic meter reading smart energy meter. So, this meter only measures the energy units and it can send it to the server. They are not having a facility of communication between the utility office and the meter. So, this is the automatic meter reading smart energy meter. The second is advanced metering infrastructure enabled smart energy meter. So, they are frequently used meters and they have a complete package of ensuring reliable and efficient energy management, and they are enable the utility company to communicate in both direction, that is from server to the energy meter and vice versa they can communicate. The company can control the consumer load from their office. If the load is more, then it can reduce the load or it can disconnect the load for a certain period of time. If suppose the sanction load is 4 kilowatt and the consumer is using 8 to 10 kilowatt, then it can stop the electricity supply by sitting at their office. So, it can restrict the customers to some specific load level. Then smart card based prepaid meter. Generally in multi-storied buildings, smart card based prepaid energy meters are used, where we can recharge like our mobile phone, we can recharge those meters, and when when consumption is done, then that amount is reduced according to the tariff, the amount is reduced. So, it has two main part, one is a smart card and other is smart card reader. So, smart card is like our credit card, credit or debit card, and it is made up of plastic and consists of different component like CPU, read only memory and electrical eligible ROMs. So, when consumer want to electricity supply, then customer can recharge the card, and this card, when it inserts the card into card reader, the card reader stores the unit that is available in the card, and then when consumption is done, the energy meter reduces the unit as much as energy is consumed. When the unit reaches to 0, then it disconnect the supply voltage. So, these type of smart meters are generally used in the multi-storied building. And next is token based prepaid energy meter. So, in token based prepaid energy meter, basically it is type of GSM meter, like we are using Geo phones. So, they are generated token, and tokens are used to recharge the device. These tokens are generated by the utility company and from the where we purchase the electricity from there. So, it consists of two EEPROMs and interface with the microcontroller. So, one EEPROM contains the recharge balance amount. EEPROM means electrically eligible pre-ROMs, and the microcontroller reads the balance and stores in another EEPRO along with the tariff. So, energy supplies plus to the microcontroller for every unit consumed. So, that the microcontroller increases the energy unit by 1 and decreases the balance amount in the EEPROM by 1. So, when it goes to 0, then it shows yes, there is no unit is used, no unit remains, and at that time it will disconnect the supply. So, these are the 4 type of smart meters that are used nowadays. Now, I will discuss the counters. Advantage and disadvantage. So, it eliminates the manual meter reading, monitoring the electrical system more quickly, tampering is not possible in this meter. So, disadvantages are that it is very difficult that many persons are saying yes, it consumes more power. So, it is very difficult to manage, and storing this the public reactions are there, and the customer acceptance is very few. And so, this vast data we need to store also. So, these are the few disadvantages of smart meters. Now, digital counters. We have seen in any digital instrument, whether it is digital multimeter or digital frequency meter or a digital energy meter, watt meter, we need counters, and these are the counters which count the number of pulses or the number of event that happens, and it stores in a place. So, there is a counter, and the second thing is that there is a display unit. So, display unit is generally used in 7 segment display units, and counter counts the number of event happens, and then it fed the data to the display unit. So, digital counters are the device which stores the number of times a particular event or process has occurred, often the relation with the clock signal. So, it is used for the measurement of frequency as well as time. Digital counters are generally we can use when we want to count a number of persons entering in a mall. Then we can place a sensor that senses ki yes person is coming, and then it generate a pulse, and that pulse is counted by the counters. So, we can use the digital counter for counting the number of persons enters in the stadium or the mall also. So, counters are of two types. One is asynchronous counter, this is also known as ripple counter, and second is synchronous counter. So, asynchronous counter, this is the synchronous counter which is having two flip flop, or we can say the two stage asynchronous counter. So, in asynchronous counter the clock is applied at one place, here the clock is applied and the second flip flop receives the output of the first flip flop. Means the basic difference between asynchronous and synchronous counter is that in synchronous counter the clock is applied simultaneously to all the flip flops, whereas in asynchronous counter the clock is applied to only first flip flop, and then the output of first flip flop is the input for clock for the second, and then the second clock pulse out the second flip flop's output is the clock for the third flip flop. So, here we can see, and in generally counter we use a T type flip flop, toggle flip flop. Toggle flip flops property is that when we toggle it, when a clock appears, then it changes its state. It means ki when it is at 0, suppose if it stores 0, when clock appears it will toggle, it will go from 1 to 0. So, or if it stores 0, then it will go 1, it will produce next when clock pulse appears, it will produce 1, and otherwise reciprocal of that. So, here when there is no clock, then no input is there and it stores 0 0. So, initially the value is 0 0. When first clock appears, because of this flip flop there is a clock, so it will go from 0 to 1. But here because the output of this is 0 at that time, so it will not trigger next flip flop, and next flip flop is at 0 state. Now, when second clock pulse appears, when second clock pulse, so the 1 is stored here, that 1 is transferred to the second flip flop, and here it is 0. So, at second clock pulse, this 1 is transferred from here to this place, and here it is 0. Then similarly third clock pulse appears, then it will change from 0 to 1, because it is 0 to 1 positive change. So, it will not affect the second flip flop, and similarly when third clock pulse appears, both will go to 1 1. So, this is the synchronous counter. In this way it will count the number of pulses. This is 4-bit synchronous counter. So, here we can see these synchronous counters are also used for the frequency divider circuit. Means suppose we can it is used in frequency counter or the frequency measurement instrument. Suppose we generated a very high frequency by using a crystal oscillator, and we want to give it to different ranges. So, for this different ranges we can use a synchronous or asynchronous counter to divide that number of pulses. Here we can see that the clock pulse frequency is we see for these two clock pulse frequency, one clock pulse one Q naught is generated, means these two clock pulses divided into divided by 2, and if we see second output of the second flip flop, then it divides it by 4. When fourth pulse is there, then it will change its state. It means if we are using number of flip flops, so the output of first flip flop will produce 2 to the power 1 divide by 2 to the power 1. Second flip flop produces divide by 2 to the power 2, that is 4. Third will produce 2 to the power 3, and 4 will produce 2 to the power 4. So, suppose we want to divide the frequency by 16 times, then this circuit is used. So, this circuit will divide ultimately the output at this end, the clock frequency is divided by 16 times, 2 to the power 4 times. So, here what will happen, the function is same as the previous circuit. The clock pulse is applied in the first flip flop, and remaining flip flop has the output connected to the remaining flip flop has the clock input connected to the output of the previous flip flop. This Q is connected to the clock of second flip flop. And here JK flip flops are used, but they are connected in the form of T flip flop. Basically J and K both are connected together, and then it is kept at high voltage, high input. So, they are basically converted into T type flip flop. So, again when this first clock pulse appears, it will change from 0 to 1, and because here this is positive change, so it will not affect the flip flop second. So, the first is changing when this is 0, it is goes from 0 to 1. Okay. Then when next clock appears, then it will go from 1 to 0. When it goes from 1 to 0, then next will go from 0 to 1. So, in this way this clock is generated, this timing signal is generated, and if we see that after the 16th pulse it will change from 0 to 1. So, this is asynchronous counter. Asynchronous counters are very easy to make, but it has a low frequency operation because the second flip flop is waiting for the output of the first flip flop, and the next flip flop is waiting for the output of the previous flip flop. So, the rating frequency of this asynchronous counter is very slow, although it is very simple to design. Next is synchronous counter. So, synchronous counter has high speed counters. Here we can see the purpose of the counters are same, that it also divides. If we are using 2 flip flop, then it will divide the frequency by 2. If we are using 4 flip flop, then it will divide by 2 to the power 4. So, but what is done here, that in this circuit we can see that input is applied and the clock pulse is applied to every flip flop. So, it means simultaneously clock is appeared at the input of every flip flop. Now, this is again JK flip flop. So, it is converted into T flip flop, and then it is connected with high voltage, high input, and we can see that because of the counting, we know that it will start from 0 1 0 0, then 0 1 1 0, then 1 1. So, we can see that when both this is 1 and this is 1. So, the output of both, output of this and output of this, both are fed to the AND gate, and AND gate, and we know that AND gate has an output when both output high, when both inputs are high. So, when the both output of both the flip flop will be 1 1, then only that AND gate will produce 1. So, it will produce output 1 when both the inputs are 1 1, then it will produce 1 AND gate, and when next clock appears, then this flip flop will change its state from 0 to 1. So, it means they will change from 1 to 0 and this will change from 0 to 1. So, the next after 1 1 it will read 1 0 0. Similarly, the input of this flip flop, here the input of this flip flop is through this output of third and output of this, means when both flip flops are 0 0 0 1 1 1, then it will produce 1 and then next flip flop will change its state. So, that is shown here, that in first clock pulse the output changes of Q1 output changes from 0 to 1, then next clock pulse it is changes from 0 1 to 0, and then when the second clock pulse of this appears, then it will change the Q2 is changing its state. It means these are the divided by counters. Now, the most commonly used counters are decade counters. Generally in any display unit we need to count the number from 0 to 9, and when it goes from 0 to 9 and when 9 appears, then it should produce 0. So, this type of decade counter is used for this purpose, and here we can see that this is 9, when 9 means 1 0 0 1. So, when 1 0 0 1 appears, then it changes its state. So, here we can see in the diagram that the first is Q1, here the clock pulse is applied, and this is a synchronous counter, and the output of this 1 means first and last. So, here we can see that this flip flop, output of this flip flop and the output of 1001. So, output of this AND is connected here. Okay. So, 1010 is connected here. So, after here when this 1001 appears, then this NAND gate will give 0 output to all the, it will provide a clear signal to all the flip flops, and this flip flop will go to 0 0 0. So, this is the decade counter. So, decade counter has 10 different states, and after 9 it will go to 0 state. So, these are generally used for the measuring instruments, decade counter, because the 7 segment display which is used to display the units, that also display from 0 to 9. So, this has. Now, application of digital counters. So, digital counter convert, and it is used for the analog to digital conversion. So, in analog to digital conversion, these counters are used, it converts the analog signal into digital signals. Then it is also used for the timer circuit. Suppose we are using in washing machine. So, suppose we fit the timer, the time period for the washing of the clothes. So, after fitting the time period, this counter will start counting, and when it reaches that value, then it will stop the function. It will send a pulse and it will stop the function of the washing machine. Similarly, triangular waveform generator we use in the digital counters, and digital counters are also used in digital clocks. And the practical application, as I have already told, we can calculate the number of persons that are visited to the stadium, mall and auditorium. So, we can keep counting of those persons. So, this is the application of digital counter. Thank you from my side.